Hello, I'm Alex Lindsey in the Department of Horticulture and Crop Science, and today I'm going to talk to you a little bit about emergence patterns, particularly with thinking about corn and soybeans as farmers are getting ready to plant, potentially as early as this week. We know that the days suitable for field work throughout much of the Midwest have been going down over the last 30 years, largely due to some of our weather patterns. We're getting more frequent rain events or heavier rain events, which limits the number of days we can get into the field. And so farmers may end up pushing planting before a weather front comes through to ensure they get their crop planted, even if it could mean cooler temperatures or even heavy rain leading to standing water in those fields. Because if they don't get the crop in, they may not get it in for another week to 10 days. And we know that planting date is really important for corn and soybean growth and yield potential. But what could those implications be on germination and emergence? So let's think first about germination. The process of germination in seeds occurs kind of in three phases. The first phase is imbibition, where that seed is sucking up water from the soil and begins to swell. That's a physical process. It starts to activate some of the metabolic processes inside of a seed, but it's mainly physical in nature. The next step is really where we see that metabolism kick up during the second phase of activation. And the third phase is active growth, or radical emergence is kind of the key for that. So then we start to see the radical come out and the shoot come out, which is looking to find the soil surface to break through that level. So what can we expect with regards to how long this process takes until we see emergence? In corn, some of the work that we've done here at Ohio State suggests that 150 heat units accumulated in the soil environment is needed to get to about 50% emergence of our crop stand. 90% emergence occurs at roughly 180 soil heat unit accumulated heat units. And so what this means from a temperature perspective is that if we have warmer days or warmer soil conditions, this will happen in fewer calendar days. If the days are cooler, it's going to take longer calendar days for that emergence threshold to be achieved based on heat unit accumulation. This uniformity of emergence is really key when we think about per plant yield, and that the plants that emerged within 3 days of one another didn't really see a yield penalty, but plants that came up after that period tended to have slightly lower yields than their early emerging partners in that field. By no means were they weeds, they still contributed to the yield productivity of that field, but it wasn't as much as they possibly could. So when we think about corn, under cool conditions, we're going to have slower emergence. We get a lot of questions about imbibitional chilling, but this is really unlikely. That would really occur during that first phase of germination when the seeds are sucking up water from the soil. If the water is really cold, we might see imbibitional chilling injury, but that's really only susceptible for the first 12 to 24 hours after planting. What we're more likely seeing is cold injury from the cold temperatures after the seed has imbibed and is entered into that active growth phase. And so if you suspect we're having issues because of cold temperatures, I'd look at digging up some plants and looking for kind of that twisted mesocotyl in corn, like we see in the picture here. Other issues if we plant before a strong storm event could be that heavy rains deposit standing water on the field. This could lead to soil crusting in those environments, which is more challenging for plants to emerge through, but it could also lead to saturated soil conditions. If the temperatures are cool, corn tends to tolerate those better than if the temperature is hot. So hot, standing water is more detrimental to corn after planting than cooler conditions that have standing water. As long as that water recedes, though, those plants may still have a chance to emerge from the soil. When thinking about replanting decisions, consider the stand that you have, as well as your original planting date to make those determinations. In soybeans, our seeding rates tend to be a little bit higher, and so the emergence window ends up being a little bit more diffuse. Some of those early emergers, as that growing point comes out of the ground, it may be susceptible to cold temperatures, but there may be others that can germinate later to help take those plants' place in the event of death because of cold temperatures. Cool temperatures does slow soybean growth and development, leading to longer periods of susceptibility at young vegetative growth stages to some pests like slugs. And it also could mean slower canopy closure being achieved, which could have implications from a weed control perspective. So in summary, emergence is really driven by soil growing degree days. The cooler the temperatures are, the longer that emergence window is likely to take as well. When concerns about stand do arise, you should check within the row for those seeds. Remember that imbibition or seed swelling because of moisture uptake from the soil will occur regardless of if that seed is alive or dead. And so what you really want to look for is if there's a radicle or a shoot that started to emerge from that seed to make sure it wasn't imbibitional chilling that caused the damage. You should look for patterns in the field because it could indicate other issues may be at play other than just stand viability due to seed issues. And always consider stand that's left and planting date as well as current date when making those replant decisions.